Okay, we got a little more than halfway through Chapter 7. We covered all the material with the exception of plotting library that they wanted to talk about. So I'm going to jump down to that slide, and it's titled Plotting Data with Matplotlib. So this is a package that allows you to create two-dimensional charts and graphs. So the other important thing to notice is this is one of the ones that is not part of the standard Python library, which means if you go in and say import matplotlib, it's going to tell you that it is not found. So we'll talk about how to install it here in a moment. I haven't decided yet if I'm going to have you all use this library, and if I do, will we do it on the Grace server, or will I have you install this package on your local machine? So I haven't quite figured that out yet, as I said. But to install things, there is a command called pip, and when version 2 of Python coexisted with version 3, if you're using version 3, which is the current version of Python, typically you're going to say pip3 to make sure you get the pip version that goes along. So pip is Python installer, and basically what you do is sudo is the Unix command to make you the super user or the root user so that you have access to install things. And then pip3 is the command we want to issue as root. And then install space package name. So what will happen is this will install this package that we might be wanting to use. And it notes that in Appendix F of your textbook there's more information about the pip utility that you might want to look at in general. So this is a library, so whether we're writing our own program or if we're using idle, we're going to have to use the import command to import the particular package. If you simply get the prompt back, that means that it imported the library function correctly. If for some reason you didn't run pip or it wasn't successful, you will get an error message when you try to import a package. There is within this library a module called pyplot, and you will need to import that. And what you want to do, or the reason they're doing this, is they're using as PLT. So we have a relatively long name to the module, which is matplotlib.pylib. I'm sorry, pyplot. But we'd really like to refer to it something shorter. So in this case, they've used PLT as the shorter name. There's a plot function that allows you to create line graphs. Line graphs have an X and Y axis, and you will supply coordinates, and then lines are drawn from the first coordinate to the next coordinate to the next coordinate. So here's a sample graph that was generated with the plot function. This is the program that they used. So basically what happens is we use list. We have two lists. One of them needs to be the x coordinates and the other needs to be the y coordinates. And since these are two-dimensional coordinates, there needs to be the same number of elements in the x coordinate list and the y coordinate list. So basically what happens is they generate the plot with plt.plot, and then they do plt.show to actually display the graph that was built. As far as the x and y coordinates, what you're plotting, you may not want to start at 0, 0 and go to whatever the maximum values are, like we did on the previous slide, to get the graph to fit on the picture. You might want that. I can't think of a situation where you'd want it smaller, but you might want it larger for some reason. So what you can do is you can call the x limit and y limit commands to specify the minimum value and maximum value of x, and then with y limit you're specifying the minimum value of y and the maximum value of y. And then that would be, if you will, the graph size or the window size of your graph, and your data would be plotted within that window. You can put tick marks at the bottom. Sometimes these are values like 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. For example, if you were plotting a percentage, what they're showing you here is on the x coordinates, they are having years, in particular the years between 2016 and 2020 inclusive. And on the y-axis, they are, it looks like it's using millions of dollars. So 0, 1 million, 2 million, 3 million, 4 million, 5 million is what that looks like to me. So here they're going through and they are giving you the coordinates, building a graph. They're putting a title on the graph, which is sales by year, and then they are labeling the x and y axis. Then they're putting those tick marks we talked about. They're adding a grid, so we have a grid pattern on our graph. And then finally they're saying show the graph that I have created. Doing that, it will look like this. And what they've done is they've kind of denoted how did we get different things. Like we got an X label years, we used X ticks to get the years down at the bottom, etc. So what they've shown there is kind of really common information that you would have on a graph. If you want to create a bar graph instead of a line graph, there is a bar function that does that. It needs two lists. It needs the x and y coordinates. Well, actually, the first is the x coordinate of the bar's left edge, and the other is the height of each bar. So instead of being positional coordinates, they are the two dimensions, or related to the two dimensions we have on the graph. So here is what this would look like. So we're just simply doing a bar graph, telling where we want the bar placed on the x-axis and how tall we would like the bar to be. As far as the width, it is 0.08 along the x-axis, and you can change that by passing a third argument. So you'll notice down when we called plt.bar, we still have the left edges, we still have the heights, and now we have a bar width, which is now 5. You can change colors of objects in the plotting library. We do that by passing a single letter color code to it. So, for example, B is blue, G is green, etc. So you can change those colors. If we do that, we did this with a named argument that is color equals, and then a color for each of the bars that we have. And we're going to add X label to put the labels there. We're going to use X ticks and Y ticks to mark our axes. And then we're going to call pyplot, the pi function of pyplot to generate a pie chart. When you call a pie chart, you send it a list of values that represent the size or the quantity or the value for each slice of the pie. What that's going to do is it's going to add all those values together and then go back and calculate the actual size of the pie slices out of the whole pie. So here we have 20, 60, 80, and 40. And when we plot those, it's going to use its choice of colors to generate the pie chart. And then, of course, plt.show is going to show our pie chart. You can add labels to your pie charts for the different slices, and that is a list of strings that is passed. Again, this is a named parameter, labels equals, and then the name of a list that contains the labels in the same order that the values were placed in the list above, in this case the list named cells. Here are the order of colors that it will use. So if you have 5 slices to your pie, it will take the first 5 values and use them. However, using those single letter codes again, you can go through and change the color order to something else. Okay, so that finishes up Chapter 7. We have a list of things we learned here. We have lists and tuples, which we did in the Part 1 lecture that hopefully you've already seen. And then today we covered the last bullet point, which is plotting charts and graphs with the Matplotlib package. So, like I said, that finishes up Chapter 7 of your textbook.